Hello and welcome to the Useful Formulas and Function in Excel 2 webinar. My name is Amit Khandakar, a specialist in the area of data analysis and machine learning. I welcome you to this webinar that is offered by Continuing and Professional Education Directorate at University of Doha for Science and Technology. Before we head on to the webinar, to this exciting webinar, and let me also inform you that this is a continuation to our previous webinar where we have looked at the interface, built-in and user-defined functions, cell referencing. In this webinar, we will be exploring some more useful functions in Excel. Here is an overview of the topics that will be covered during this webinar. We will be exploring some advanced logical functions in this webinar, such as SUMIFS and COUNTIFS. These are advanced logical functions than the one that was seen in the previous webinar, which is SUMIF and COUNTIF. SUMIF and COUNTIF is again an advanced version of the functions sum and count. After exploring SUMIFS and COUNTIFS, we'll be looking at a very powerful and commonly used function in Excel, which is if. We'll be exploring an advanced version of if, which is called as nested if. So we'll be looking at the tips and tricks of using such nested if functions. Then we will be following up on another important and commonly used function in Excel, which is called as VLOOKUP, which I'm sure which will be very handy for many of the operations and tasks that you do in your office. Finally, we'll be exploring functions that can be used with text inputs, such as concatenate, left, find, and examples will be shared for all of them in a manner that will interest you more to explore these functions further and also encourage you to look for other available functions in Excel. Without further ado, let's head on. COUNTIFS is another commonly and powerful used logical function. COUNTIFS is used to count cells when many conditions are to be met, unlike COUNTIF where only one condition has to be met. The syntax for COUNTIFS is shown here, where COUNTIFS needs the range and the conditions. So there will be criteria, range, and the condition. Then there can be criteria, range 2, and the condition, and so on and so forth. So there can be many criteria, ranges, and the respective conditions. Let us take an example to understand it better. As usual, we will always try to understand the data before we try to use it in our calculations and analysis. So this is the same data set that we have seen earlier, where we have the dates, sale representatives, the state where the sales are done, the products that are sold, the company that it is sold to, and the total of those sales. Now, the manager has asked us to show the count of sales done in different states for different products. So now we have two conditions to be met before we can count. This is the best place to use the logical function COUNTIFs. Thus, we go to the cell I2 where we have to find the count and use the COUNTIFs function here. So the COUNTIFs function over here will count the number of sales done for the product stethoscope in the state Michigan. So as usual, equal to COUNTIFs, double click, we open the formula function bar, formula dialog box, I'm sorry. Our first criteria is we want to find the count of sales done in the state Michigan. So we go to column C, and the criteria is Michigan. The next criteria is we will be looking for count of products stethoscope sold. So criteria range 2 is the product column, and the criteria is the product stethoscope. As we are inputting the arguments, we have to make sure we know that we will be copying the formula to the different cells so that it can be automatically updated. So we have to know the cell, the rows, and the columns that should not change. In other words, we have to use relative and absolute referencing. So we don't want the criteria range or the columns to change. So we will put a $sign in front of them. So same thing, the $sign in front of them. The condition is states, which is in column H. So the column doesn't change. So we will put a dollar in front of the column name. The rows can change. Similarly, the product is in row number 2. It does not change. The columns change. So dollar in front of the row name. So we have 83 sales done in the state Michigan for the product stethoscope. Once again, as we are inputting the arguments, we know the column H, which contains the state's name, don't change, and also the column C and D, which consists the state and the product's name, also don't change. Similarly, the row 2, which contains the product name, does not change, so we put a dollar there. Okay. Once this is done, we can confirm the dependencies by going to formulas and trace precedence, which shows that this cell uses I2, H3, column C, and column D. We remove the arrows and we will copy it to the next cell, and just confirm the dependency here, just to make sure that the referencing that we did are correct. So it is referring, it is counting the number of BP machine sold in the state Michigan, and it's referencing to J2, H3, column C, and column D. Let's copy it to the right and then to the bottom. Let's check anything randomly. Trace precedence. Very nice. It is counting the number of glucose analyzer sold in the state of Michigan using column C and column D. So COUNTIF is different than COUNTIFs. In COUNTIF, we have only one condition that has to be fulfilled. In COUNTIFs, we have more than one condition that has to be fulfilled before we start counting. SUMIFS is another used, commonly and powerful used logical functions. SUMIFS is used to add the cell content where many conditions are met. The syntax for SUMIFS is shown here, where obviously as we write any formula equals to SUMIFS, and in the arguments we give the range that we want to sum, the criteria that has to be fulfilled, the range of the criteria with the condition. When that is met, we sum that cell content, and obviously there can be many criteria. So this is criteria range 1 with the criteria range 2, criteria 2, and so on and so forth. Now let us take an example to understand this better. So we will use the same data set that we saw earlier, where we have date, sales rep, state, product, company, sales total. Let us hide that. Now, the manager has asked us to find the total sales done for different products for to different companies. Now, this is the best place to use the function SUMIFS because we have more than one criteria that has to be fulfilled, and after the criteria are fulfilled, we will add the total. So this is the best place to use the SUMIFS. So we will go to the cell P2 where the formula will be input, and over here we will try to find the total sales done for the product stethoscope to the company Acme Medical. So obviously we will do equal to SUMIFS. Now this time we will try to use the formula itself without the box, and then we can repeat it with the formula dialog box. So it says sum range, so obviously we will be summing the sales total, then comma, the next thing is the criteria range 1, so we will be looking for the product stethoscope in the product column, so that's the range, and the product is stethoscope, comma, we will be doing it for whenever the company is Acme Medical. Now, before we close the bracket, we have to make sure that we have used proper absolute referencing, as this formula will be copied to different cells afterwards. So in order to do that, we need to know the rows and the columns that don't change. So obviously the sales or the sum range should not change. This remains constant everywhere. So we will be putting a dollar in front. Similarly, the product that is being referred to, product column does not change, so that remains same as well. The product that is the condition of the product, which is P2. Now, as we can see, all the products are in the row 2. So in this case, row 2 doesn't change, the column changes. So we will put a dollar in front of the row number, and the column number can change. Again, the second criteria column, which is for the company, does not change. Over here, the company is in column O. The rows change, so we will put a dollar in front of company, and then we close the bracket and enter. So that is the sales total for the product stethoscope when it is and it is sold to the company Acme Medical. The same thing, let us just copy this over here. No, sorry, yeah, we can copy this over here, the number, and we can do the same thing again using the formula dialog box. So equal to sum if s, let's go to the box, the formula dialog box. The sum range is sales total, and as we said, it does not change, so dollar and dollar. Criteria range 1 is product, it does not change. Criteria is stethoscope, it's in all the products are in row 2, so the row number should not change. Range 2 is the company, which should not change, dollar, dollar, and the criteria number 2 is the company. Over here, all the companies are in column O, so the column should not change, and the answer is 151,967. That's what we got. This is obviously dollar, so we will just change the format to dollars, and the same thing, we can confirm the precedence using formulas. Trace precedence, which is correct. Remove arrows, we can copy this on the right. This kind of things is because of the column width, we'll increase it automatically. We'll copy this down, and we will once again check trace precedence. So this is glucose analyzer, medical supply company, column D, column E, column F. Remove arrows. So that's another example where the sum ifs is used, and it's a very, very useful formula. Having understood the different commonly used logical functions, it can be explored further in different scenarios and the working confirmed before it is used with expertise to automate error-free analysis. Instead of doing it manually, this is done using formulas and functions and absolute and relative referencing to make sure that our analysis is error-free. Now, another very useful logical function is if function. If function is used to check for a question and take action when it is true or another action if it is false. The syntax for if function is equals to if, open brackets, the condition, the value if this condition is true, the value if this condition is false. Based on the syntax, the best way to work with if function is to prepare a diagram as shown in this image and then develop or input the arguments. So you have a question and what will you do if it is true and what will you do if it is false. So once you have that, then you use that diagram to as to develop the arguments for the if function. We will be looking at an example where we will try to find if someone is an adult based on age. So let us open the Excel file, and as usual, it's always better to know the file before we make use of it so that we can properly exploit or understand the data and do our calculations and analysis. So in this file we have names, their age, and we have a category which has to be fulfilled which has to be filled, sorry, using if condition or using based on this age. So this is the best place to use the if function. Now the best way to make use of if function is, just a minute, let me move it, guys, is by using making such a figure and then writing the answers to them and then using that to come up with the if function or the arguments for the if function. Um, so we have the question over here, and what is the action if it is false, and what is the action if it is true. So this is how, and this will be used for the arguments of the if function. So as we said, so let's copy that. So this can be done on a piece of paper. I'm just doing it in Excel over here. So the question is age greater than equal to 18? That's the question. If it is greater than equal to 18, then he is an adult. If it is not, then he is not an adult or not adult. So we know the action is to print not adult if it is false, or print adult if it is true. So we will be using the if function, so equal to if, and then we can use the formula dialog box. So the condition is I want to check this content if it is more than equal to 18. That's my condition. If it is more than equal to 18, if it is true, then I want to print out adult. If it is not, I want to print out not adult, right? So that's the condition. I will check if the content of this cell is greater than equal to 18. If it is so, then I will print adult, or else I will print not adult. Press OK. Let me check if this is correct. Yes, age is less than 18, so it's not adult. Next one, adult. So as it is working fine, so I can easily copy it to other cells. So this is making use of the um, fu function formula, uh, um, the formula dialog box. We can do the same thing without it, and this will come with expertise, where if I go here, I put the condition, which is this is if this is greater than or equal to 18, then the value, if it is true, so I said I need to print out adult. The value, if it is false, is not adult. And I press enter, not adult, copy it down. Obviously, just to recall, let everybody recall, you go to the end or bottom right of the cell, you get the plus sign, click on it and drag it down. In this way, the formulas are copied. I can go here, I can do formulas, trace precedence. It's referring to this cell, so that's fine. And this kind of checking is required when you're working with a new function to make sure that you're not making mistakes. And once you become used to it, there's no longer, you don't need to check it again and again. So if is a very powerful logical function, and there can be various versions of it, which we will be looking at later on. So that's what we did. So if function is used to check for a question and take action if it is true, or another action if it is false. In order to do that, we use this kind of figures or diagram or algorithm. This can be written down on a piece of paper, or you can use the template that is provided to you, and use it for any complicated problem that you might be dealing with in your day-to-day life. um, and obviously, as you become more and more experienced, you don't even need to draw them. You can easily do it on the fly. So we have seen how to do it without the formula dialog box, and with the formula dialog box. This is a very useful way of knowing more about a function when you're using it for the first time. Hope that's clear. And it is fun, because it just lets you explore such important um, logical functions. After having seen the very important and powerful if function, we are ready to see an advanced version of the if function, which is termed as nested if, where we actually use if function within a if function. If you recall, when we are using an if function, we have a question, and based on the answer, if it is true, we do an action, or based on an answer which is false, we do another action. Now, these actions can be an if function. So previously these actions were, writing and displaying a result, but in a nested if, these actions can be another if function where another question is asked and actions taken. So an if within an if is called nested if. So it's very common, as sometimes we want to do multiple checks before taking an action. And as discussed earlier, the trick is to make the algorithm diagram first, as shown in the figure. So this is we had previously seen only one level of this algorithm diagram, where a question is asked and an action is taken if it is true, the question, and if it is false, another action is taken. In the case of a nested if, we always try to put the second if. It's not compulsory, but it's a good tactic to put it in the um, um, uh, put it as an action whenever it's a false answer. So it's a false answer. So then there will be another if question where action will be taken if it is true, and actions will be taken if it is false. The reason for making, because the question asked can always be reversed. In the previous example, the question was, is the number greater than equal to 18? Now, if I have to reverse the question to make the false as true and the true as false, I can say B2 is less than equal to 18. Over here, B2 is greater than equal to 18. The question, if I have to reverse the false and the true answer, I can just say B2 is less than equal to 18. So it's always possible to change the question so that we can have the true action becoming a false and the false action becoming a true. We'll understand this more with an example. So that's the algorithm. That's a snapshot of how an algorithm diagram can be created if we have a nested if. So we look at an example now and understand this better. As usual, whenever you have um, Excel file, it's always important to know um, the what is the data about, so that you can manipulate, do calculations and analysis and so on. So we have previously seen how to do an if function, how to use an if function for another problem. Now we will try to do. We have another problem in hand where nested if is the best solution. So this is a data set where we have the name of the person, number of years of experience in a job, question whether they have a bachelor degree or not, and then finally, based on these experience and bachelor degree, we decide if that person is eligible for job or not. So the way to get the job is if you have more than 3 years of experience and if you have a bachelor degree. So we go to our, yeah. So if you have more than 3 years of experience and a bachelor degree, so just noted more than 3 years of experience and bachelor degree. All right, good. You just wrap it so that this stays in the same. Oopsie, no, not a good idea. Okay, I can just merge them and wrap them. I can do this. Merge them. Yeah. Okay. Yeah. Do is there anything else remaining? Why don't I merge more? Yeah. Okay. Good. So that's the condition for the job. All right. So I have to do this nested if. So I'm just going to copy this diagram once again. It might be too much of work doing this drawing this diagram over in Excel or on a piece of paper, but as you get more and more experience, this might not be required. So I need to ask a question and then take action if it is true, take another action if it is false, and then the next question, because I have two criteria to be fulfilled here. So so the question is um, experience more than or equal to 3. If it is true, then yes, eligible for job. If it is not, but the problem is there's a second related question. So even if he's eligible, if it is experienced more than 3 years, I should ask the next question. So this cannot work here. I need to ask the second if to confirm if that person is eligible or not, right? So this has to be experience is less than 3 years. If someone has experience less than 3 years, then he's not eligible. If someone has experience more than 3 years, so it's a false over here. If someone doesn't have less than 3 years of experience, that means he has more than 3 years of experience. So then I can ask the next question: does he or if bachelor degree, if he has a bachelor degree, then he is eligible. If he does not have a bachelor degree, then he is not eligible. Good. Now we have our nested if diagram, and I just have to change it to the if function. So let me try. Obviously, if I look at this person is not eligible for the job because even if he has more than 3 years of experience, he doesn't have a bachelor degree. Okay, so let's go and write the if condition is equal to if. Unfortunately, this kind of nested if cannot be written with the formula dialog box. It's too complicated. So it's better to write it over here without the formula dialog box. So if the condition, as we said, if this value is less than 3, all right? This is the question that I asked. If it is true, okay, Once again, let's look at the syntax of if condition, if function, if logical test. Then what is the value if true? What is the value if false? So the logical test or the question is, if this is less than 3, if it is so, if it is true, then my output should be not eligible. If it is false, then I have the second if condition. So it's going to be an if here, and you open the bracket. And it's always a good practice that whenever you have a nested if, always open and close the bracket at the same time. And it will be really useful afterwards when we look at a much more complicated example. I go inside the if statement. So the first is the condition. So I check if this is equal to yes. That's the logical test. If this is equal to yes, then then that person is eligible, otherwise not eligible. And I've already closed the bracket, and I need to close the first if. It's always this is another very good feature in Excel where you can always see that the colors of the parentheses. So the second if had a red color to know to link them, and the first if had a black color. Okay, all right. Now, if we go and check the second one, so the way to check the second one is the same formula. I will just go to the bottom right, look for the plus, click on it, drag it one down. Now, Samir, the second person, has more than 3 years of experience and has a bachelor degree, so he is eligible. Excellent. Let's look at the third example. Sam has 2 years of experience and has a bachelor degree, but he's not eligible because he needs to have both experience and the degree. Yeah, I can drag it down. And so I'm once I have seen that it works for 2 or 3 of them, then I have the confidence that it should be working for others as well. Once again, the the syntax for if is equals to if bracket open condition action or answer when it is true, when the condition is true, answer when the condition is false. Over here we have used a nested if, and as discussed earlier, it's always better to use nested if. Change the question so that the second if is always in the false, um, is an action to the false answer. So we started the question, does he have less than 3 years of experience? If he does, then he's not eligible. If he does not, then the next question is checked whether he has a bachelor degree or not. So maybe I should put the question here equals to yes. So if the bachelor degree is equal to yes, because that's the question, that's the actual question, then he is eligible. If it is no, then he is not eligible. So that's what we did here. We said first if the experience is less than 3 years, then he is not eligible. And then the next second if came up, where we checked if the bachelor degree is yes. If it is yes, then he is eligible. If it is no, then he is not eligible. So that's a nested if. So these are just two levels. Now we can have many, many levels of if, an if inside an if inside an if, and so on. And as you can see, it's a very powerful tool. And this is an example of user-defined function. So it's a combination of user-defined function and built-in function. So I'm using if, which is a built-in function, but I'm changing it as per my need. So obviously this if is this if can be used anywhere and everywhere. You just have to be aware of your data so that you can change it and use if accordingly. Okay, now let us look at another example. So over here we will try another nested if, but this time a little bit more deeper. That means it's not only two ifs, there will be more than two ifs. So over here we have the unit quantity, and the price changes based on that. So if the quantity of suppose the unit quantity of buying a pen, if someone is buying pen like in the quantity of 1 to 10, it is $30 per unit. If it is 11 to 25, it becomes 28. If it is 26 to 65, it is 25. And anything above 65 quantity will have a special discount, which is only 22 per unit. So we have, once we mention the unit, we should automatically get the total based on these conditions. So we will be using again our diagram, right? And um, before we go ahead and use our diagram, we will just use a sample example to make sure that we are doing it right. So if we have, say, 27 units, it should be 27 multiplied with 25, right? Because this is 27 units is in between 26 to 65. So the unit, so 27 units will be priced at $25. So that's our, so we will try to see that whenever we press 27, it should give us um, $675 as answer. Now, so so we have to start with the price. So the question over here is, it's going to be quantity. Now we should be doing the nested if in such a way so that the second if is always in the false of the first if, right? The second if should be in the false of the first if. So we can continue from there. And the reason for that is, if you look at the if statement, the if statement always have the false statement at the end. So it's always easy to have, all the ifs coming at the end. So that's the trick. So whenever you have the second if in the false, then you will always have ifs in the end, always. So it's easy to track. If you have an if if it's a true, then it's always in the middle. It will be hard to track. Okay, so the first question is, let's go backwards. So if you go backwards, we will always have the if on the false. So quantity more than 65. If the quantity is more than 65, then the price is 22. Otherwise, we check quantity more than equal to 26, then the price is 25. Over here, more than equal to. So as you can see, I am getting my questions on the false of the if. So that's 25. The next question is the quantity more than equal to 11? These are questions, so I can have a question mark at the end. And then, oh, sorry. So this is going to be somewhere here. No, somewhere here. No. Oh, okay. Maybe there is a merge center here. Okay, so we go here, copy that. Okay, I can survive with that. Here, yeah, there you go. So if quantity is more than 11, if it is more than 11, then it is $28. If it is not, then obviously it's less than that, so I can just go and put it as 30. Okay, that's good. So I have put all my questions on the if, on the false of the previous if. And the reason for that is I always want my ifs to be at the end. It's easy to keep track of them as I will not be able to use the formula dialog box. So I go here, equal to the quantity term will be here. So let me just put the quantity here, 27, because I know the answer for 27 and I will check myself, is equal to if the condition, if this quantity is more than equal to 65. So that's my first question. Is the quantity more than equal to 65? If it is, then the value, true value, or the answer is it's going to be $22. If it is not, then I go to my second if as per the diagram. So second if is again if as I said, we open and close the bracket, and it's also a good idea to close the yeah. I go in and I say if the same quantity is more than equal to 26. If it is more than equal to 26, then the price is 25. That's the price if it is true. If it is not, then I ask the third question. And again, if open bracket, close. I go inside my third if to write the third and last question, which is if quantity is more than equal to 11, then the price is 28. Otherwise, the price is 30. And obviously, I did not close my first if, so I close it. And the good thing is I should have 6 brackets in total, 3 opening and 3 closing. So 1, 2, 3, 4, 5, 6, 6 brackets. So it's working fine. Press. Okay. Now, if it is 27, then the price is 25. That's correct. But I have to be doing this. This multiplied with whatever the price is. Yeah, right? Because the if that we did before gives us the unit price and we need to multiply it with the quantity to get the total price. So this has to be a currency, so we can do that. Yeah, that's a currency. So a quick recap, what we just did is we had our question, we would be given our quantity and we have to find the total. So what we did is we asked the questions to ourselves in such a manner so that the second question, nested question, will always be in the false. The reason for doing that is we always want our ifs to be at the end. You see here, all our ifs, nested ifs are at the end or on the right side. So it's easy for us to track. The other way of doing, the other thing that would happen is you would if you had your nested ifs in the true side is you would always have the ifs in the as a second parameter, which would be really hard to keep track of. But over here, this is easy to understand or keep track of the parenthesis and understand how it is going. So we ask the question, we put the nested if on the false always, and then we just put the, we use this diagram to fill up the syntax, and that's what we did here. So we already knew a sample answer and we did it over here. We can check it again before giving it for use to anybody. Suppose we had only say 5 units. So if we have 5 units, the unit price would be $30. So this multiplied with 30. One more last. Suppose we had 13 units. So if we had 13 units, our price should be 13 multiplied by 28. Yep, it's working fine. So a takeaway from here is you always have to understand your question or your data properly. Use the data to come up with the nested if. The only way to come up with a good nested if algorithm diagram is if you understand the data. So we can ask the question in such a manner that the nested if is always in the false, and then we keep answering it and have this diagram ready and use this diagram to come up with our nested if. That's what we did here. Whenever there's a if, nested if, always open and close the bracket so that it's easy to keep track of them at the end, because whoever uses if first time, nested if first time, they always have problems with the number of brackets, and this can be frustrating. I understand that. Oh, sorry. After having seen all these complicated, not complicated, useful nested if, we might end up with issues with simple things. Um, for example, over here, this is another example where we have a list of activities mentioned here, such as director's report or tasks that are supposed to be done by team members. And there will be a remarks tab, a remarks column where the date when it is done is written. We want an automatic status update whenever a remark or whenever a date is mentioned of when it was done. So the status will be saying that this activity is still open because no action is taken, or closed when an action has been taken. So the different activities, for example, director's report to be finalized and sent for review. An action has been taken on the 1st of Jan 2018, so the status over here should be closed. Finalized annual report should be open as no remarks. AGM notice was sent on 15th of Jan, so it should be closed. Prepare attendance register, no remarks yet, so this will be open. Ready the documents needed, no remarks yet, so it will be open. Follow up with auditors, no remarks, so it will be open. Now, obviously, this thing over here, doing it manually, is error prone and time consuming. Now, we can use an if function over here to make it closed or open based on remarks entry, right? So if I just go ahead and take this, so I have a question because I'm going to use an if condition. So I have a question and the answer is the answers could be closed or open. So closed or open. Now, so the question is remarks is equal to, or if the remarks is empty, right, there's nothing there. If there's nothing there, that means it is open, otherwise it is closed. So yeah, that makes sense. That's easier to keep track of, because if there's nothing in remarks, then it is an easy solution that it is open. Otherwise, if there is something, then it is closed. It might be a date, or it might be action taken, and so on, right? Let's not complicate it now. It can be made a little more complicated by using nested if based on the needs, right? But over here, just we want to know if it is open or closed. So it's going to be an if function, and because it's just one level, if you want, you can use the formula dialog box. The logical test is I want to see what is there. If it is empty, right? Now, okay, if it is empty, then it is open, otherwise it is closed. All right, good. And if I just drag the formula down, once again dragging the formula down is going to the bottom right and dragging it down. So closed, open, open, open. Now, some of you might say that I don't want to do like that. I want to say if not empty. So if remarks is not empty, then it is, sorry, if remarks is not empty, if the question is remarks is not empty, then it is open, otherwise it is closed. If it is not empty, or if it is not empty, so it is closed and this is open. If it is empty, then it is um, open, right? But it's not empty. There's something in it, so it's closed. And if it is empty, then it is open. In that case, this is something that I've seen many people suffer with because they don't know how to write not equal to here. So the best way to do that is equal to if, again, dialog box, if this, that's not equal to empty. So this, um, greater than equal to together is the meaning of that is not equal to. It's not equal to empty. If it is not empty, then it is closed. Otherwise, it is open. The good thing with this is I don't need to put the parentheses. It automatically puts the parenthesis because it's not a function anymore. So this is the other way of saying not empty, right? This is equal to empty. This is not equal to empty. So that's closed. Bring it down. Open, closed, open, open, open. So that's something else that many people have suffered with is coming up with not equal to. So after having looked at all the important functions or commonly used functions so far, there's one more commonly used function or a function that is used a lot of times. I've seen many people inquiring more about it, and it's very commonly used function in offices, and it's very useful. And that function is called as VLOOKUP, which is vertical lookup. Um, VLOOKUP is a function which is used when we need to find things in a table or a range of row. So as the word says, look up, look for look for something. The way it works is it looks for a value in the leftmost column of a table most of the time, and then returns a value in the row form, a column you specify. So you have a database and you have two databases with a linking term, linking common row, or linking common column between them, and you want to take a value from the second table in the first table. So you will be looking or you will be using this VLOOKUP function. By default, the table must be sorted in an ascending order. So the second table where you'll be taking the values from after lookup should be in ascending order. All of these will be clear once we do an example. In its simplest form, the VLOOKUP function says, so we're looking at the syntax of VLOOKUP equals to VLOOKUP. This is not the actual syntax, but this is a simplified version of it. What you want to look up, where you want to look for it, the column number in the range containing the value to return, return an approximate or exact match indicated as true or false. So it has four um, arguments. So what, the value that you want to look up, the where do you want to look for it, the second table in our case, the column number in the range containing a value to return. So in that table, which column number value will be returned back, and whether you want an exact or approximate match, which is either by 1 is an approximate and 0 is a exact match. So that's the syntax. We look at it again at the end to understand it more. Maybe once we see an example and how it works, this will become more and more easier. So the VLOOKUP function, the by definition in Excel is looks for a value in the leftmost column of a table and then returns a value in the same row from a column you specify. By default, the table must be sorted in an ascending order. It has four variables it needs: lookup value, the table where you want to look for the value, the column number in that table that you want to bring back, and whether you want an exact or an approximate match. So in order to understand the full utility of VLOOKUP, we will be looking at an example workbook, and that workbook has a database where you know there are people and the violations that they are doing, and then there is another column which is the fine based on the violations. So this is the summary, or this is what the data is. Details contains the names of people and the violations done by them. And then there is another sheet, fine, which contains the fine to be imposed based on the violation. So one way of doing it is, okay, overtaking, fine is 50, so right over there. Overspeed, fine is 800, write it over there. Mobile while driving, fine is 300, and so on. Another way is by using VLOOKUP. Um, the good thing about VLOOKUP is I don't have, the fines might change at any time, and I don't have to go and change them over here. Instead, I will just go and change in this table, and it will be automatically changed over here. So I don't have to give access to this table to anybody. Only the managers have access to it, and the managers can change the fine based on the government rule, right? So let's do an example of this, and let's understand the utility of VLOOKUP more. Once again, as discussed, it's always important to understand the utility or the details of the Excel file. So I have names of people, the violations done by them, and the fine based on those violations. And I have another table, another worksheet where I have the the violations and the fines based on that. This should be traffic light. Yeah. Okay. Good. Okay. So in between both the tables, violations is common. Before we continue with, I we know that we always want to look for this violations in this table and then get the fine from that table over here. So the best way to do that is by using VLOOKUP. And this is the table where we'll be looking for the terms. Obviously, as we said, as mentioned, the second table should always be in the ascending order. So we will make it in ascending order. So we select it, we go to home, filter, sort, highest to lowest. Oh, sorry, I should be sorting this. So only this, only the fines, right? This is the value that we'll be sorting. So sorting from, no, sorry, this is the value that it's going to be looking up for. So we want to sort this, sort from ascending order. So lowest to highest. Yeah. So MOOT, right? So the table is sorted in ascending order, and the thing that should be it should be ascending order based on the value that we'll be looking up for. Okay. Now we go to this table, and this is where we want to put the value after getting it from this table. So we go and say equals to VLOOKUP, double click. We are ready to take arguments, so we can use the formula function, formula dialog box. I call it like that. The lookup value is a value that I'll be looking up, or the value that is common between them is this. The table where these values will be looked up is this. Sorry, not this, just this. That's enough, right? And the value that will be copied to, or the column number that will be copied, is the second column. And we will be exploring this range lookup. So if I make it false, it will be an exact a match. True, it will be an approximate match. So let us make it as an exact match. I want it to be exact, right? So Amit has done overtaking, so the fine should be 50, right? So it works fine. Good. What if I made it true? That means it is not an exact match. Okay, no problems. Yeah. Um, it's always good to make it false, because false for I wanted an exact match, because otherwise what happens is it will take decision when even there is slight matching of the lookup values. So it's always better to um, make it exact match. We can do an example to understand it. Suppose this is overtaking and we make this overtaking. Okay, yeah, overtaking. Yeah, you see here, this is overtaking and that's overtaking. Now, because they don't match, it takes an approximate uh, similarity with overspeed and makes it 800. Now, if I make this false, the range lookup as false, where I want an exact match, in that case, it will just show me an error that he did not find anything, which is much better, I think. So if I just make it overtaking, then it works fine. So that's the importance of the range lookup or exact match. Okay, so that goes over here. All right, now there is problems here. Now I have to copy that down. So I did that. If I go to overspeed, or if I just go mobile while driving, there is mobile while driving, but it shows not applicable. The reason for that is if you go and look at the values, it is looking at B5, that's correct, B5. But when it goes here, it is looking at values A4 to B7. Now that's the problem. I wanted it to fix here. Now it is shifted. This is the problem because of relative referencing. So to fix that, I have to go to find and say that this should not change. This value or the table should be fixed because this lookup table does not change. So there should be absolute referencing here. And now if I copy the formula down, which is just go to the cell, go to the bottom right, bring it down. Let us confirm overtaking mobile while driving is 300, mobile while driving is 300, and so on. So it's working fine, and I can just keep updating it. At any point of time, the management thinks that, you know what, we want to impose strict restrictions on mobile while driving. We don't want to make it 300, we want to make it 1500. And I don't have to worry because automatically whoever has done that unfortunately will have to pay more money. That is just by changing the um, value over here where it is referring to. So that's the utility of VLOOKUP, a very powerful uh, Excel formula and very commonly used. I'm sure that you are already having ideas of how to use it in your work life. Okay. After having seen the lookup, one of the lookup or reference function VLOOKUP, we can look at a similar function which is HLOOKUP. So HLOOKUP is similar to VLOOKUP where it's H, it means horizontal lookup. So the syntax are almost similar where you have lookup value, table array, But instead of column index number, which is vertical, we'll be looking at row index number, which is horizontal. So let us look at an example to understand this better. As usual, whenever we have an Excel file, it's better to understand the data so that we know the context, and then we can explore it or do our analysis calculations on top of it. So this is an Excel function where we have the student names and their corresponding marks in different subjects. Uh, and we have been asked to find the marks of a student Donald in management. So we have to look for Donald and then look for the value uh, horizontally over here, because it's not vertical, it's horizontal. Whenever the management term is, uh, whenever there's a management term, like whenever the lookup value is management term, the lookup term is actually Donald, and we'll be looking at the fourth column from here. So that's first, second, third, fourth. So let us look at the horizontal h lookup equals to h lookup formula. We go to the function dialog box. The lookup value is D, and we can say star. That means anybody with the name D and so on. The table array is over here. So it's going to look for D in the table array, and whenever it gets it, it will go and look at, obviously we have to make sure that this doesn't change, so it's fixed. We will go and look at the row where which we will be referring to. So over here we are looking for the value in management. So we go, so over here, which is row number 1, 2, 3, 4, row number 4, and we want exact match, false. So it finds the marks of Donald in management, which is 72. Um, we can let this input be, you know, be a cell reference in future versions. I'm sure you know how to do that, but if I want, I can change it to say A star. That means anybody whose name starts with an A, and that should be 70. Suppose I say row number 2, that means it will give us the value of it will give us the marks of Amy in uh, account subject. So this is horizontal lookup. Again, recap, lookup value, which is represented with A and star. That means anything that starts with A. The table array that we want to look the value in, the row number whose value will be sent back instead of the column which was in VLOOKUP. This is horizontal lookup, and range lookup is false. To be honest with you, HLOOKUP is not as popular as VLOOKUP, which we have seen earlier, but because we were looking at lookup and reference function, so it was a nice time to explore a similar function. Many times in Excel, I'm sure you would agree with me, we deal with files where we have to, you know, perform operations on text rather than numbers. The best example that comes to my mind is where we have list of names, and then we have to the names are divided into first name, last name, and then we have to combine them to make it a full name. Or we might have a full name and we have to get the first name from there, or the last name from there, or we have to put a designation um, to the full name or the first name, etc. So these are all operations where we have to deal with text inputs and combine them, split them, and so on and so forth, rather than all the experiments or all the examples that we have seen till now where we are dealing with numbers. So we will be looking at some of these examples where functions can be used with text inputs. We'll be looking at functions like concatenate, left, find, and so on, based on the context. Obviously, we know that whenever we have heard of a function that can be useful, we can always go and look for more details about it from the formula dialog box. So this is the details about concatenate function. This is the detail about the left function, and so on, right? Let us understand this more with an example. So, so this is an Excel file where, you know, as it sometimes comes from the Oracle system or any database management system, we get a list with the names, with the first name and last name separated. Now, we can have different needs from this kind of Excel file, sometimes where we just have to add a designation to, to the names, right? Or we have to combine them and get the full name for printing on ID cards, for example. Or we might have the full name and we have to get the first name from that full name. So name with designation, that means just, you know, for example, all of them are males here, coincidentally. So I just have to put Mr. in front of the names. So the best way to do that is with the help of a function which is called as concatenate, which is combining, which just means combining. So let us look at an example first. Equals to concatenate joins several text strings into one text string. So double click. So it just says inputs are the things that you want to combine. So before I go to that, I wanted the full name because that's easier. So equals to concatenate. So I want to combine first name and the second name, right? So last name, sorry. So I need to put a comma. So I put a comma and I put the last name, and that should be all. Close the bracket, enter. Oopsie. Now it seems he did not put any space between the first and the last name. So I need to put a space in between them. So the thing that I can do is, after I say the first name, I put double inverted commas with a space, comma, the second name. So it's the first name or whatever is in B2, then a space, and then the second name. Okay, that's good. Let's copy to the second one. It's Majid Abdul Jabbar. Yeah, that's fine. So I can just copy it to the end. All right, that's good. So yeah, so I got my full name from the first and last name using the concatenate function. Now the same thing goes with designation. So I want to put a designation in front of all the names. So it can be equal to concatenate. Right, let me make it bigger. Equal to concatenate. Now designation would be Mr., right? So Mr. Then I want to have a space. So space and then the first name, Mr. Abdullah, right? Just let's take it to the second one, Mr. Majid, and I can just copy it down. Now we had put. Now you might have a question. Oh, why did you put two inverted commas? Why not just put a space in between? Okay, let's see if that works. So Mr. space first name. No, it doesn't. It needs, so we need to put the space in between inverted commas. If you don't put the inverted commas, no matter how many spaces you put, it will not recognize that. So I have to put inverted commas and then space in between them. Okay, so far it's good. It looks fine. Now the trick is how to get the first name from full name. So let's hide all of that. Now I am trying to get the first name from the full name. So obviously it's Abdullah, Majid, Kareem, Ahmed, Mahdi, Anas, Abdul Majid, and so on. So how did I get the first name from the full name? Obviously, I read it from the left until I identified a space, right? So whenever I see a space, I stop there, and whatever I see is my first name, right? Saud, Helmi, Abdurrahman, and so on. So the trick is I'll start from the left until I see a space, right? So I'm starting from the left. So I will use a function left. Returns the specified number of characters from the start of a text string. So it says text and the number of characters, right? So let me take an example. So that's the text. And I want to take 1, 2, 3, 4, 5, 6, 7 characters. Yeah, that's good. Now if I take it to the next one, oopsie, it doesn't work because he is taking 7 characters. M, 1, 2, 3, 4, 5, 6, 7. So this is not going to work. I need to find an automatic way to come up with this number 7, which is the count before the space, right? The space is the 8th term over here. 1, 2, 3, 4, 5, 6, 7, 8. 8th term is the space. I took one less than that to take my um, first name. So it can be fixed by using a function that can find the space. So find the space. So the function that I'll use over here is find. find returns the starting position of one string text string within another text string. So find, it needs, what am I, so the syntax is find text within text and the starting number, right? So I am finding text space within text this, right? And starting number, not exactly sure what that is. Starting number is specifies the character at which to start the search. The first character is permitted start numbers. So I can put a number there, or I can just exclude it. So I'll put a number 1, for example. Okay. So it's looking for the space in the term Abdurabu and starting for the first term. So it's 8. Okay, that's good. And 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 obviously I will just close the bracket. So it will start from left on this term and continue until it finds the space, right? Okay, that's good. Abdullah, very nice. Majid, Kareem, Ahmed, and so on, right? Good. Now, how many characters are here? If I just write length, okay, I want to know how many characters are here. So obviously the characters are 1, 2, 3, 4, 5, 6, 7. Abdullah has 7 characters. So I can know the length of any text by using the function len. Okay, length. It gives the length of any text. So length of this should be 7. Oopsie, that's an 8. Length of the term Majid should be 4. Uh-oh, it's 5. Length of Kareem should be 1, 2, 3, 4, 5, but it is 6. The reason for that is we are going until the space. So we should go 1 less than the space, right? We should take only 7 terms instead of 8 terms, because the 8 term is the space. So we should ignore that. Then if I go here, it's Majid. Now it makes sense. It's 4 terms. Then I can copy it to all of them, right? This is a very important thing, because sometimes the space, you don't find the space when you look at it because you don't see it, but it is actually hidden there. So we have to be very careful with this kind of details. Obviously, you don't have to worry. This comes with experience, and we can always debug where the problem is. Now, can we do something similar where we want to find the last name? I'm sure we have always come across this kind of questions where we have to find the last name from the full name. All right. Let me just put that filter there. Okay. So we'll be putting the last name from full name. So obviously over here we use left to find the first name, and the last name is over here. So we can do, obviously the last name over here is Abdul Rabu, Abdul Jabbar, Abdul Elenin, Abu Zar. So the trick is always go till you find the first space. Right? You go from right till you find the first space, and that's your last name, right? Um, so the trick is over here is equal to write text and number of characters. So for number of characters is you go till you find the space, right? But remember, find, as we saw before, find always works from the left, not from the right. So even if you take that, or let's do that, find space in this character, and then if I do that, okay, that worked. Let's go check the next one. That didn't work. It makes sense because it it will go from the space is after is in the fifth place, right? So it will go from one from the right, one, two, three, four, five, fifth term. So that's not helping unless I subtract the whole length from that. I say that you will take everything after you find the space. So in other words, I would say find the length of this term minus whenever you get the space. So from the right, take all that letters. So what I did over here is I took the length of the whole full name and I subtracted the length or when the position of the space. So by doing that, everything else is my last name. Total length minus the space, the position where the space is found. We'll remove the first name. Whatever is remaining is the last name. So I'll go from the right and take all that characters. If I do that, Abdul Rabu, next one should be Abdul Jabbar, next one should be Abu El Lenin, next one should be Abu Zor, next one should be Ahbabi. Al Ahbabi, yes, because he goes till the first space, then Al Dabak, and so on. So the trick was making use of the terms right, left, finding when a space is, the logic that we use whenever we are trying to find the first name and the last name. Excel functions that or details about some of the Excel or more details about how many functions are available and what all things you will be exposed to in during an actual course. So if you look over here, we have some sample examples of around 202 Excel functions with examples of how to use them in a scenario. And there is a reference document which talks in details about the various functions available in Excel, what is the syntax, what is the description of it, what are the syntax of it, and how to make use of the Excel file. So, for example, there are functions for date and time. So, it talks about what is the date function. It says the date function in Excel is categorized under Excel data time functions. It is the main function used to calculate dates in Excel. The date function is very useful for financial analysis because financial modeling requires specific time periods For example, an analyst can use the date function in Excel in their financial model to dynamically link the year, month, and day from different cells into one function. I'm sure the people who are working in finance have to deal a lot with cash flow, a lot to deal with interests. So they need to know what is the difference between the date input earlier and today's date. So all of that scenarios, the date function comes really handy. So it not only tells you about the date function, but also examples of where it can be useful. The date function is also useful when providing dates as inputs for other functions such as SUMIFs or COUNTIFs, since you can easily assemble a date using year, date, month, and day values that come from a cell reference or formula result. So that's the syntax. Date requires year, month, and day, and it tells you more about what is an year, what is the month, and what is the date. What is the day? Um, this is a required argument. The value of the year argument can include 1 to 4 digits. Excel interprets the year argument according to the date system used by the local computer. By default, Microsoft Excel for Windows uses the 1900 date system, which means the first date is January 1st, 1900. Month, sometimes some arguments are required or optional. So over here, year and month are required argument. It can be a positive or a negative integer representing the month of the year from 1 to 12. Excel will add the number of months to the first month of the specified year. For example, date 27-14-2 returns the serial number representing February 2nd, 2018. When the month is less than or equal to 0, Excel will subtract the absolute value of month plus 1 from the first month of the specified year. For example, date -32 returns the serial number representing September 2015. So in other words, um, these descriptions over here not only talk in detail about what is the function, how it is useful, more details about the formula or the syntax and the arguments that are used over there, and some examples of how to use the date function in Excel. And we have examples, various examples of them. Um, so that's only date function. There is dated if function. There are examples of them. There are examples of rundown and various versions of all the Excel that you see there. Date value function similarly. So in that manner, it is not only showing you what is the description, how to use it, even screenshots of it. So we will be going through some of them in the next webinar, um, and looking at some examples that are very much related to the day-to-day uh, work or professional work life. Some of the important functions, these are all functions related to date and time. EO month is end of month. That's a very important function that is used in financial modeling, used by financial modeling people. That's an information function is ISO week number. Finding out the ISO week number for of the year for the given date value. Minute function. So it's very there are a lot of very useful and handy functions that are available in Excel, and based on the question in hand, we can explore the one that might be useful. Time function. Today, a very important function in Excel that tells us what is the day today. So if you just use the formula equals to today, it will tell you today's date. So on and so forth, right? We will be exploring some of the functions from here. For example, if, um, VLOOKUP, concatenate, left, right, find. Uh, so that's a document that will be available in an actual course, and some of them will be practiced in the session and is also looked in this webinar. These are the files that will be used during the exercise. Finally, we reach to the end of this webinar. I hope you enjoyed this webinar. Remember, this is just the tip of the iceberg. There are still so many things that Excel can help us with and can be explored further. I'm sure we can do it together in another sessions of webinar or an actual session. If you have any questions or for more information about the professional training programs offered by the Continuing and Professional Education Directorate at UDST, please contact the CPE team through the email or phone number provided here. Once again, thank you so much and hope to see you soon in another similar webinar.